This video is all going to be about station number 4, the factoring level 2, where we have a mixture of all the different techniques in our flowchart. In every single one of these problems in the flowchart, the first thing we ask is there a greatest common factor? Okay, so let's do that real quick here in number 1. Is there something that both of these two terms have in common? 2 and 20 are both divisible by 2. So I know there's going to be a 2 as a common factor. If x and x squared, both of which are divisible by x. And since that first term is negative, the x squared term is negative, I'm going to factor out a negative as well. What's left behind? 2x times something gives me negative 2x squared. I have the negative 2 already, so that part isn't missing, but I am missing an x, so I'm going to put an x there. Negative 2 times negative 10 gives me positive 20. That x is there. Okay, that's factoring out the GCF. And then we look at what's left behind. Do we have a binomial of 2 terms or a trinomial of 3 terms left behind inside the parentheses? Here we only have 2 terms, an x minus 10. Is that a perfect square minus a perfect square? No, neither one of those is a square, so we are done. That is the end of that problem. Number 2, what do negative 7 and negative 4 have as the greatest common factor? If I look at 7, that's 1 times 7. 4 is either 1 times 4 or 2 times 2. The greatest factor in between them is 1. But since that 7 is negative, I'm going to go ahead and factor out a negative 1 from that. Is there anything else I can factor out of both of those? Again, I have x squared and x. I can take an x out of each. So let's put that before the parentheses. What's left behind? We need a 7 and an x from that first term. And we need a 4 from that second term. Inside parentheses, that is a binomial, and it is not a perfect square minus a perfect square. We're done. That is the end of that problem. That is factored. Number 3, 3x squared minus 14x minus 5. Is there a greatest common factor amongst all 3 of the integers, all 3 of the numbers? 3 is 1 times 3, but 3 does not go into 14. Only 1 does. So 1 is our greatest common factor here. That's not very helpful. Can I take an x out of every single term? X there, but no x's here. So I can't take an x out of everything. The GCF is just 1. The first term is positive, so I'm not going to take out a negative there. We don't have a GCF we need to worry about. Okay. Do I have a binomial or a trinomial? 1, 2, 3 terms. 1, 2, 3 terms, which means it's a trinomial. So we're going to try and factor it like this. When we do that, we're always going to start with our leading term, our leading coefficient of 3. So we're going to put 3x in one of the blanks and x in the other one. There are opportunities at times where there's more than one way to factor that first term, but here 3 is the only way to do it is 3 times 1. 3 is prime. Okay, then we need to figure out how do we get to negative 5 by multiplication. Well, there's only 1 times negative 5 or negative 1 times 5. Those are the only ways to get negative 5 by multiplication. Some combination of those is going to give us what we want. I'm going to use 1 and negative 5 and hope that that works out. I'm going to put a 1 in the first blank, so plus. I'm going to put minus 5 in the second one. If I multiply that out, 3x times x gives me 3x squared minus 15x plus x minus 5. That's minus 14x. That's what I want. So this is our factored form. Cool. Number 4. Number 4 is interesting because the x squared is not the first term. So I'm going to go ahead and first just rewrite this so that it's in standard form. Okay. negative 2x squared plus 10x. We always want to try and write it when the exponent is in decreasing order. Okay. Does this have a GCF? Yes. 2 and 10 are both divisible by 2. We have x squared and x. Both of those can be divided by x. And since that first term is negative, let's pull out a negative. What's left behind? 2x times x is 2x squared. And negative 2x times negative 5 gives us positive 10x. What's left behind is a binomial. And it's not a perfect square minus a perfect square. We are done with that problem. Moving on. Number 5. In number 5, do we have a GCF? Well, I've got x squared. Oh, there's no x on that last term. So there's no common factor of x. 1 is the leading coefficient, so we can't factor out anything other than a 1. There is no GCF that's helpful here. This has 2 terms. It is a binomial. And we said when it's a binomial, we go here and say, is it a perfect square minus a perfect square? X squared, perfect square, x times x. 25, perfect square, 5 times 5. That means we are here on the flowchart. It says factor via difference of squares. Now, a reminder what that means. A difference of squares was one of those special kinds of factoring where we could rewrite this as x squared plus 0x minus 25. That might help you if you need that. But x squared is x times x. To get negative 25 by multiplying, we've got to go negative 5 and positive 5. And since we have opposites, the middle term will cancel out and become 0. This is that difference of squares process. Number 6 follows almost the exact same process because 100 is obviously a perfect square. 49 is a perfect square, and x squared is a perfect square. Everything there is a perfect square. So we can use our difference of squares property the same way. The square root of 49 is 7. So we've got 7x and 7x. The square root of 100 is 10. So plus 10 minus 10. When you multiply all that back together, that middle term will be 0. The linear term will be 0. So if we see a difference of squares, use that process. Number 7. Okay. Do we have a GCF? No. Whenever you see a 1 as a coefficient, you're not going to have a GCF we need to worry about, and we see a coefficient of 1 in that linear term. So we know that that's not going to be very helpful for us here. We have 3 terms. It's a trinomial. So we know we need parentheses and parentheses. If you notice, number 3 and number 7 have a lot in common. They just have parts in different orders. Okay, we still need a 3x and an x to get us x squared, 3x squared rather. Then, how do we get negative 14 by multiplying? 1 and 14, or negative 1 and 14, negative 2 and 7, negative 7 and 2, negative 14 and 1. Which combination of those is going to get us a positive 1x in the end? Again, if you end up, you may have to try multiple different solutions until you find the one that actually works when you multiply it back out. So let's see what happens if we put negative 7 here and we put plus 2 here. If I multiply this out, I get 3x squared plus 6x minus 7x minus 14. Oh, that's a negative 1x. Okay, so we have an issue that did not work. Let's find a different solution. I'm going to erase this. What do we need to change? What we need to do here is, let's try, what if we switch the signs on the 2 and the 7? Okay. What if instead of this being positive 7, or negative 7, we make this positive 7? Instead of being positive 2, we make this negative 2. Typically, when we have the middle term become the opposite sign, we change the signs of those two, we're in good shape. Let's multiply it out now and make sure. 3x times x is 3x squared. 3x minus 2 is negative 6x. Plus 7x minus 14. Oh, good. That's positive 1x. This is the factored form that we're looking for. Because of space, I erased the other thing. If I had more space, I would keep track of all my thinking and then just make it very clear which one it is that works. That way I don't make the same process multiple times, okay? Number 8, do we have a GCF? 5 is divisible by 1 and 5. 21 is not divisible by 5, so not one that's going to be helpful. 21 and 18 are both divisible by 3, but 5 is not. So no GCF to worry about. This is a trinomial because it's 3 terms, and when we factor a trinomial, we try and do this. Okay. To get 5x squared, the only way is 5x and x. How do we get 18 by multiplication? We can do 1 times 18. We can do 2 times 9, 3 times 6. Some combination of those should hopefully work for us here. I'm going to go ahead and tell you, if we put plus 6 here and plus 3, that will, in fact, work. Multiply it out, check that that is the case, but we get 15x and 6x, which makes 21x's. Number 9. Is there a GCF? No. Rats. Okay, so we know we have 3 terms. It's a trinomial. I'm going to put parentheses, because that's how we factor a trinomial. To get x squared, we need x times x. To get negative 18, we got negative 1 times 18. Negative 2 times 9. Negative 3 times 6. 4 doesn't work. 5 doesn't work. 6 does. So negative 6 times 3. Oh, that's just the reverse of what we already had. So these are all our factors right here. Which combination are going to work? If you're starting to see a pattern here where when it's 1x squared, we want them to add to positive 3. Which ones add to positive 3? Oh, those might be the ones to try. Negative 3, positive 6. And it turns out that, in fact, that is the factored form that we want. Now, if you notice, on number 10, I've gone ahead and made a change on what the problem says. I've changed it to 6x squared plus 9x minus 6. So I want you to use that instead. So cross out what it said and go with this one. Does this have a GCF? Yes. Every single one of these terms is divisible by 3. So let's factor out a 3 first. If I pull out a 3, 6 divided by 3 is 2, so 2x squared. 9x divided by 3 is 3x. Negative 6 divided by 3 is minus 2. Okay. What's left behind? This still has 3 terms. It's still a trinomial. So when we go to factor this, I now know that I want 3 times some linear term times some linear term. To get 2x squared, I know I need a 2x and an x. To get negative 2 by multiplying, I need either negative 1 times 2 or negative 2 times 1. The question is, what arrangement? I'm going to tell you, I know I'm not going to put a 2 here. And the reason being, is if that was the case, there would be a bigger GCF. I know if I have a 2 and a 2 and they're both divisible by 2, we'd have a bigger GCF than what we pulled out. And we don't have that because 9 is not divisible by 6. So I'm not going to put a 2 there. The 2 has to go over here. And the 1 has to go in here. The Question is, which one's positive and which one's negative now? Because I want positive 3x, I need this product right here to be the positive 1 plus 2, because that'll give us 4x's. And then the other one, I'm going to go 2x minus 1 minus 1x. That's going to give us a negative 1x together, positive 3. So the factored form has the GCF pulled out as well as the two linear factors. All right. Good luck with the rest of your studies. Let me know if you need anything.